All right, this is actually take two of this stream 8. I realized on the last stream I completely did the entire stream with the main title screen showing the entire time. So everything I talked about and was trying to show, I could not show. Um, so real quick here, we're going to make this one a little bit quicker. I do want to say that the original intention of this next series was to actually build the player inventory system, which we talked about in stream 7. But I got a little sidetracked, and actually looking into that, I realized that's going to be one that's going to take probably multiple streams. We're going to have to break it up in segments. The first thing being building our actual UI for the player inventory, which I'm going to have to investigate the Unity UI system a little bit more and see what functionality is available or what components they have that can be used to facilitate that, and then decide what do I need to do from scratch versus what's already there that can make this happen. The second part of that is building the pickup system and putting in those collisions for that to make sure that items can be picked up when the player interacts with them. And pressing the letter E for a pickup, or maybe we'll do P for pickup. Keep it trying to match. What. Anyways, so we'll come up with all that. What key sequence is going to be pressed for that? It'll probably be P because I actually want to reserve Q and E for a possible lean left and right. We're gonna A and D are going to be a strafe left and right. W and S would be forward. We're already using the mouse for movement. Q and E will be like more of a lean left and right, and so we'll probably do like a P for pickup. I will be for inventory, and then the third phase of that will be implement once items are picked up and they're in the player inventory, and we've got all that tracking right and the ability to move stuff around in the different slots in the player inventory backpack. We want to make sure that once that data is stored in the game here, that it's properly accessed and maps out to the correct placement of the items that were picked up. So if you've got a weapon in your primary slot, we want to make sure that it's then in the player's hand and facing in the right direction, and those kind of things. If you've got a melee weapon, we're going to have to decide: is this going to be is it a one-handed weapon, or is the player going to hold it in two hands? So there's some tweaks that are going to have to be made to make sure that the player's arms and hands and the object itself is in the right position to make it look realistic, along with being able to interact and use some of the items that are picked up, like first aid kits and the consumables, like the water as well, and other things, the attachments for the gun. So there's a lot of stuff going on with that. So it's definitely going to have to be broken up into a number. I can foresee at least 3, possibly 4 or 5 series stream for just start to finish completing that player inventory setup, and along with the pickups and allowing it to work, the items work in the world. We still would have to build like some stats, stat bars, some way to represent player health on the screen. Rather, I don't want to just have numbers. I mean, I could do that to make it easy. Just have hit points in the top left corner, like hit point value and the stamina value or something like that. Or I think the sprint is not going to be an unlimited sprint. It'll be based off stamina, and I'm thinking about using the drink, which is the bottled water, just for like an overall well-being, which when you drink that, your overall health and increases both your health and your stamina, get a boost, and later on, unless I can get some food items and other kind of drink items, we can do a separate hunger and thirst stat that we can track, and we'll have to come up with some stats that we want to track and implement the ones we can now, and set it up in such a way that we can easily build additional stats. So I did watch some cool information on building stat bars and representing them on screen. I saw one that I really liked the way the guy did it, and so I think it's the approach I'll take with this. Anyway, so yeah, so for this video series, this stream we're doing right now, I just want to show what I did do because I want to do something that I could actually get done and show on this stream, and so with what I just talked about, it's going to be a lot. I couldn't do it in like a 1 hour stream. So what I was able to do was, I wanted to eventually have a mini map and a compass type system built into this game, and so that's just what I have here. And what I wound up doing was I took look at our hierarchy here for the project. Down in our resources prefabs folder, in our player folder, we have our only player, which is the built-in player controller that comes with Unity. But what I added to it was another camera. We had our initial player camera that follows him and gives you the view behind the player as you're moving around the 3D world. And we had some scripting in there to help control that camera and make sure it's moving and rotating the same way as the player. I added a second camera called a top-down camera, and essentially what I did was I set it to actually, let me change it. I just want to change this to match. Well, it doesn't really matter. First of all, I set it up so that it was directly on the player position, so it's located at the same X, Y, and Z the player position, and then I altered the Y value, which is the Y position, so that it would raise it up in the sky at a certain height. And you can see right here at the top in the transform component, the position, the Y value is set at a pretty high number, 994 point some change. It was actually 995. Somehow it moved when I hit that. And then I rotated it. You look in the rotation segment here. I had to rotate the camera on the X-axis by 90 degrees so that it would, because initially it's pointing straight forward, like parallel with the ground, in the sky though, 995 meters up. So I rotated it by 90 degrees so it faced down at the terrain, our map here, and get a top-down view. And so that's the camera setup part of it. And then we added I added this script here, which exposed two variables. One is the height, which actually I reset it at 750. So even though this is a 995, when this is ran, and I set it here so I can play around with that Y value, it reassigns the height in this script based on what's set here. And it does each frame to make sure, you'll see why when we get to the script. And it also passes in a reference to the player controller object, which is basically just I think I'm passing in the entire game object, and we'll get the transform off it and reference either position as needed. So that's essentially that. Now if you look here, a camera that is not let's compare to our main camera here. Look at our main camera. See, this is actually designated as main camera. It's a special tag that's in Unity here that will automatically get your perspective view off the camera, and it'll show whatever is in it. It'll be your default camera that's showing your 3D scene. So it doesn't use this target texture here because it's set up as the main camera. Like I said, it's a special tag used within Unity to identify your main camera, and that starts out what's going to be your rendering to your player's eyes, their view on their screen, the main camera. And so it maps to display 1 basically, which is right here. The interesting thing about Unity is that actually, in my one of my early videos, I came across this thing that was showing display 1 through 8. I did find out those do actually represent physical displays that could be installed or utilized within the game. Now, if the player doesn't have those displays installed, then it's you really can't use them. But there's a way to see what displays are available and utilize multiple screens in this game. So by default, everything's going to display 1. It says no cameras rendering because we're not actually doing anything right now. We're not running the game. It won't render until the game runs. And that's because this camera, our player camera, which is our main camera, is attached to our player controller, which is actually a prefab. It's really just a resource in our it's like an asset that is not, it's instantiated during runtime. As soon as the game runs, we instantiate it. See, if you look down at our scene here, you don't see any player object here. That's why it's not, you don't have a camera view shown here, because it's not rendering yet. It's not active. There's not an instance. So anyways, that's why that's shown that way. But anyways, we added this top-down camera, and I went over the basics on that. And the other thing we also added was, well, first of all, I created a text object that would display this title and this information at the top of the screen. The Harvest Project by Michael Trippy, aka Johnny Rush. Michael Trippy being my real name, Johnny Rush being my online handle for when I play games. Johnny Rush is one of the ones I've used. I've used Lord's Archon as well, but lately I've been sticking with Johnny Rush. And I was doing some stuff on Twitch, so if you want to check out my Twitch channel, it's XX Johnny Rush XX. That's my Twitch page where I've been where I did some streams of the gameplay that I had done over the last 6 months, I guess. But I got tired of doing that, and I decided I was going to move into this building these games, and I'm streaming it on YouTube on the educational channel there. So, but anyways, I added a 2D UI text element, and by default, anytime you add a UI element, if you don't already have a canvas in your project in an event system, Unity will add those two. Well, first of all, your UI items need to be contained on a canvas, so it'll make it a child of a canvas, and then it'll add the event system to your scene as well. So let's close this up. And then the other thing I did was add a second game object under the canvas, and it was just basically an empty game object. And you see the difference in the transform. It's called a rect transform. So when you add a any UI element or an empty game object to a canvas, because the canvas is based off a 2D coordinate system, X and Y only, because it's overlaid. It's actually an overlay that shows up on your screen, and it's generally used for things like mini-maps. It can also be used for your stat bars and scoring, anything that's shown on the screen while you're kind of overlays your 3D scene. It's in a two-dimensional view. It's only using X and Y. It basically maps out to your pixels in your screen, and also it updates or modifies the transform to reflect that. That's what I was going to say on the rect transform. Instead of a standard transform, which will have an X, Y, and Z component, you see it has a rect transform, which has some slightly different things, along with some anchors to allow you to specify on your screen. You want something to anchor to the top left, top right, in the center. And then you can adjust it with the size and different offset values. But and the pivot. Pivot is used when you're doing rotations, which all your rotations will happen, even though it's only in X and Y to represent these 2D UI elements. If you're going to rotate, it uses the Z value of the transform. When you're using the vector 3, which has a Z value, it'll use that as effectively the pivot point or rotational point. So, there's a pivot point, and this here is set as 0.5 to 0.5. These values can range from 0 to 1. So 0.5 to 0.5 means directly in the center of that item. So the mini map, which we have here, was positioned down here. And if we expand that out, I want to show you, we have down here the Minimap Shape, which this is actually, the Minimap Shape is actually it's been combined with the mask, the Minimap Mask, which is a child of that, because it started off as a square, and by putting the circular mask, I was able to clip the square image. Because if you look at the first one, it actually was an image, and the images are generally, the width and the height was 250 by 250, and which was a square, and then I applied this Minimap Mask underneath that to make it round, which basically cuts off. You can see it uses this as a mask. So wherever there's transparent pixels, it'll not show that on your actual map. That's how I made it round. And then under that, we have the Minimap render, which this here is just a canvas render. It's a raw image. There's a UI element called a raw image, and the raw image, there's an image and a raw image. An image is just that. It's just a 2D sprite, basically, and that's it. It's basically a static image. The raw image is basically like a blank, transparent canvas or image. It's a blank it's not really a canvas, but it's a blank, transparent image. But it's a special kind of image in that it can take data, and it has a script that is attached to it, which is a Unity script that's built in when you use this UI element. And what it does, it takes an input source from a render texture, and then you just drop that render texture in this texture property, and whatever's on that render texture, that's what shows in your raw image every frame. And so now the render texture that I set up, let's go to I created it under assets here. We've got a render texture folder, and I labeled it top down. I just called it top down render texture. That's the name of it. It's a 2D. Its size is 256 by 256, and I really just went with the basic settings in that. And so this texture here that I created, this render texture, I took that as a material and dropped it into, let's go back to our Minimap renderer, dropped it into the texture property here. Now, if I didn't do anything more with it, you basically would just show a black, minimap here. So the way we get our render texture here to get an updated view every frame is we take the output of our top-down view camera that we added, which I mentioned was on our player controller in the prefabs here, player right here, our top-down view. And you see here the top-down view camera, it has, since it's not the main camera, the output has to go somewhere. And so if it's not the main camera, the output has to go either to another camera, or you can send it to a target texture, which has to be a render texture. And so here it is. That's where we dropped in our render texture. So whatever this camera sees, which is in our, like I said before, we went over how it was set up. It was above the character, 995 meters up, looking straight down above the character, the player. And it renders that to the render texture, which is a raw image. And, well, actually, it's a render texture, and then the raw image takes the render texture as an input to display its real-time rendered contents onto the raw image surface, which is then shown in our view. So that's kind of how they work together to come up with that view. And so let me just hit play here so you can see how our camera looks. So if you look in the bottom right corner, that's what we have. It's showing a top-down view. Even though we're inside this building, we're getting a top-down view because we're way above it. And you can see there's a little gray blurb there, which is the representation of this building. But if we kind of, let's move here. Let's move out. Oh, I'm hitting the wrong key. I'm hitting E. So as we move, you can see, you'll see, and we can rotate. It's showing about where we're at. That little gray spot you see there is that building. So that's basically how that's looking there, how it renders it. So it's rendering what it sees from that camera, from the top-down view, onto that rendered texture, which shows up over there. So let's stop that. Okay, and let's look at the script that made that happen. It's actually pretty simple. If we look here on this player, on our top-down camera, well, let's step back. I want to show you that on any of this, the actual Minimap that we set up, you'll see I'm going to click on each component. Other than the standard scripts that get added because of the type of object this is, those are Unity built-in, like an image. That's the script they put when you create another image. And then we have a raw image. There's a script for that. But those are scripts that were built in Unity. Minimap. Oh, this is one other thing. This minimap icon. This is just a raw image as well. And I took the because this little icon needs to be changing its position and all that. You know, it needs to go in the raw image. But anyways, you just drop that in there. There's nothing special about it. I created a Minimap player icon texture, which included this 2D sprite. And let's go ahead and look at the images folder again. Go down here. So we have our Minimap texture, and actually that changed because it should be like the Minimap compass that I put together. This is just if you look down here, it's just a transparent image. It's got the ring with the north, south, east, west on it, and the dimensions of it were the same as our original image for this, which was 250 by 250 roughly. And I played around with the numbers. It might be a few pixels more each way, but I got it to a size where it would overlay nicely over the this top-down camera view here. And you see the texture type is set to sprite 2D UI, and texture shape is 2D. And this texture here should have been set the same way, even though it is working, I guess because it's on a raw. There's a sprite 2D. Yeah, it has to be changed to a sprite 2D. And you gotta hit apply. You'll see it automatically changes the way it looks there. That's our original image. I think what happened is I dropped it in, then I changed it on the actual, not on the original, I changed it here on this instance of it, the Minimap object. So at any rate, it should be set up that way in your master images here, so it's already set, ready to go. So there's nothing there, but what I was getting at is there's no scripting that was done on my part for this. This is all a visual thing that's laid out in a child-parent relationship and getting everything laid out the way it needs to look in a certain order. And the only thing that really takes this Minimap shape, that's the circle mask. And then we have our mini mask. And then our mini map. So it's all nested underneath that. Let's close this off. All right. So let's go to the scripting. The only scripting that was added is, let's go back to our player. I kind of got sidetracked on showing that. I just wanted to show really that there was no script set up there. It all was done on the top-down camera that we added to our player. Again, essentially what we're doing, since we already have, once you have everything linked together properly, like this top-down camera, is rendering what it sees to a render texture, which is the one we created, the top-down render texture. And then you use that render texture somewhere in your 2D UI, which I used in this compass here. Then that's all linked up together. You don't need to worry about it. You just need to worry about making sure that top-down camera is then following the player and continually looking in the proper rotation angle and all that. So I went through a bunch of stuff, bunch of material online, because this is something I had never done before, of course. All the stuff that you're seeing is stuff I've never done. And they had some elaborate examples on how to do it, and there were some that, you know, had 3 or 4 lines of code, but it still was a lot of calculations, a lot of different things to get it done. Ultimately, none of that worked for my scenario here. you know, because every situation is different, but and maybe I'm implementing mine a little bit differently than others, and I found that it was easier to do it this way on here. And so what I created was this script called World Camera Controller script, and okay, the other thing I want to remove, and I hate to be sidetracked, when you add a new camera, by default they come with an audio listener. You only need one audio listener in your project generally, so I disabled it, but really I can just remove that component. We don't need to have that audio listener. There's already one on the player controller here, and it does all the audio listening for the entire project, and so we'll work with that later on when we start dealing with mixers and stuff. Okay, let's jump back here and then look at our, we're going to jump to the script on that. So here's our world camera. Let me remove some of the stuff I have commented out so we can show you how simple this actually was. And so we have, what's shown in the inspector here are these two public variables here. We have the height, which is of type float, and we have a game object player, which we dropped in a reference to our player, and we set the height to 750. If we look back here, you see we got 750 and a reference to our player controller. So now in the script itself, we also need a reference to the compass sprite. So we look back real quick here. Let me click on right here, the Minimap compass image. That's this right here. And I tagged it with a special tag I added called compass. And so that's the actual compass portion. The other center part is just our render texture that's showing the camera view from the top-down camera. So the actual compass portion is just a sprite image that we're going to rotate in its center point, you know, in the direction that we need to, that follows the player, basically. Whatever direction the player is turning, that's the angle that we want to rotate this. So let's go back to our script. So I set this up as private, and I used in the start function, which is only called one time when this actual instance is executed. I get my reference to the compass object with this statement here, game object that find game object with tag, and in quotations compass, which it has to be upper, it has to be typed out exactly the way I set up the tag in Unity. And so that gets our reference to the compass and stores it in the compass variable here. Now in the update frame, this is where all the magic happens with this very little bit of code here. This is called once per frame. And so these first two lines are what makes sure that the basically those are making sure that the camera, the top-down view camera, is following that player. And so the first line of code is just taking the player's position from the transformed component of the player object, game object, and just assigning it to transform.position, which is the transform of our top-down camera. See, this script is attached directly to our top-down camera, so just by saying transform or referencing that without anything before it means we're referencing the transform of the current game object, which is our top-down camera. So that's kind of shorthand. I could have typed out the long way if I wanted, but why do that? Why confuse things? So anyways, that gets the position. Now, the player position, obviously the Y position, which is the height, how high that that player is off the ground, is not going to be the same as our camera. So when we assign that, it does erase or wipe out the Y value. So the simple correction for that, what I did was add to the current position, which is now set to the player's active current position. I add to it a new vector 3, and by putting 0 in the X and the Z components, it doesn't alter that because we want to make sure that that doesn't change. But we do want to raise it back up to the original height of the camera, which again is why we have this height value in the inspector, which we set to 750, and so every frame it makes sure the The camera is at a height of 750. Now the camera itself doesn't do it. The rendering portion doesn't happen until the update functions are completely completed in all our game objects within Unity. It makes sure that all this code is executed before it actually does the visual update of the rendered items, or before it does the rendering. Let's put it that way, the physical visual rendering. So you can adjust anything here in this update function, and you'll know that it's guaranteed. The user will not see any of these changes until the very end. So you're not going to see stuff like the camera drop down to the ground and then suddenly pop up. The user will never see that. The player of your game will never see that, because again, that stuff, the actual object's new rendering position and rotations and everything that affects that object is not done until after 100% of this code is done in the update functions. So these two lines of code will take care of that. It rotates and positions the camera for the minimap view, which means once it's rotating, the camera itself is sending that new, what it sees, in the world to the render texture, which is then written out to the raw image that's within our minimap view. So that's it for the code, really. Very little. Making sure we preserve the height, getting a reference to the player, copying that over, and then all that. So 2 lines code. Now the second part here, since we are in code looking for the game object that has a tag of compass, we want to make sure that if for some reason that fails, Unity fails to find that game object during runtime, it'll assign the value null to compass. So we want to check that. If compass is equal to null, denoted by 2 equal sign, that means is equal to, we're not going to assign null to compass by using 1 equal sign. We're doing a comparison. So it's 2 equal signs. And so if compass is equal to null, then we'll log a message to our console using debug.log. The compass is null, and we just return, which immediately returns out of this function, which means it returns back to whatever called this, which is Unity, the runtime, and so it never executes these 2 lines of code, which is what we want, because they're based off of the fact that we have a valid compass object. So we don't want it to execute. But now if we do have a valid compass object, compass will not be equal to null, which means it won't log this and it won't return. It will do this stuff here, and again, I'm logging 2 things here because I wanted to make sure these were right. I actually logged them before I decided to use them. But after reading the documentation and going through several examples, and like I said, I looked at probably a dozen examples on how to create a compass, and they all had different ways of doing it. But I did notice one thing that through the documentation is that every transform has this thing called local Euler angles, which is I believe it's a vector, vector 3, that has the absolute angle of rotation for the various 3-dimensional components, x, y, and z, of a 3D object. Now, the one that we're kind of interested in, like when the player rotates left, left and right, if the player was standing still, rotating left and right, the player object is actually rotating on its y-axis. And so I went ahead and displayed out the y value and saw that the local Euler angles showed consistently a positive value between 0 and 360. If we went left or right, it was always positive. It didn't matter. It showed the correct angle going clockwise from starting at 0, heading and looking in the north direction, go all the way around. No matter what direction I went, it always showed the correct absolute angle of rotation for that axis. And so I knew that was the angle that I needed to use that value somehow in some way to rotate the 2D sprite, which is our compass sprite. I needed to rotate that on the UI, which if you research the UI runs in a 2-dimensional space. It doesn't use X, Y, and Z. Well, it uses Z in another way, but so essentially items are mapped out into X and Y axes because it's, it uses a rect transform, which, the x is left to right and the y value goes up and down, and the z is actually used as a pivot point, and you can do rotations. The value, you can use z in various ways, but z is with this local Euler angles. If you were to adjust the local Euler angles of a 2D sprite, it will rotate it by that angle, by that absolute angle, on its pivot point, which you have to really know what your pivot point is depending on the shape of your sprite. It varies, but for a rectangle that has even sides, essentially a square, where both sides are the same, the pivot point is almost always the direct center, unless you've made some manual adjustments that offset the pivot point. So in our case, if we just jump back to Unity here, our pivot point for this sprite, this compass sprite, is exactly in the middle, right here. If you can imagine a dot where west and east, north and south, the imaginary lines cross right in the center, it's right at that pivot point. And so that's our pivot point. So and I'm rambling on again, but I wanted to explain that because the pivot point matters when we're using this local Euler angles value, and especially the way I'm rotating it here. And so we can directly set the rotation, what we call the absolute rotation of a 2D sprite, by reassigning the values that are encompassed that transform dot rotation. We can assign it, but in order to get absolute values, you have to use this quaternion structure here, and it has a built-in method called Euler. If we hover over that, you can see what it does. Well, first of all, we have to pass it in a vector 3. It takes a vector 3, and then it returns back a quaternion rotation that rotates z degrees around the z-axis, x degrees around the x-axis, and y degrees around the y-axis. And so, obviously, there's certain things we don't need to mess with on this. For example, we don't want, since we're working in since our 2D sprite for the compass is in the UI, we don't really want it to rotate on an x or a y axis, because essentially what that could alter the shape of our compass number 1, because it almost would almost be as if the compass itself started doing a somersault in its current position, on the map, on the screen, not the map, but the screen in that lower right corner. Think of it doing a somersault, forward somersault. I mean, if we were to rotate it on the x-axis and the y, it would do a left to right kind of spin in place. If you took think of a hula hoop, if you took it on the ground and just held it up on the ground and spun it, you know what I mean, and it would spin that way. Yeah, we don't really want to have it spinning that way. All we want to do is take that. If we had that hula hoop standing, let's say touching the ground, we're holding it up and we're holding it like a steering wheel in a car. All we do is want this thing to rotate like we're turning a steering wheel in a car. We just want it to rotate. And so in order to do that, you can set, if you know what angle you want to set it to, you can directly assign that absolute angle value to the z component of this vector 3 that's being passed in here as a parameter to quaternion.euler. And so that's exactly what I do. We know that the y, so going back here, the player's local Euler angles.y value is the value that gives us the exact angle, absolute angle, that we want our 2D sprite to rotate in, the direction we want it to rotate in. So we're going to plug that value in as the z value into this vector 3. And then in order to preserve our 2D sprite's current rotation along its, if you can think of a 2D image rotating in the x-axis, that's like doing a somersault, and then the other way in the y. We want to preserve those. We really don't want it to move, because otherwise the shape gets kind of, starts spinning, almost like a three-dimensional object. We don't want it. So In order to preserve that, we just pass in the current x and the current y Euler angle values in this vector 3, so that we're basically preserving them. If we were to set those to 0, we'd wipe them out. It would alter the image or the rotation of that. So we want to preserve it just by setting those. If you look at the last parameter that's passing this vector 3 that we're creating here, it's player.transform.local Euler angles.y. So that gives us the value we need. So now that creates that vector 3 that's passed into Euler, and like magic, it craps out a rotation that's preserved on the x and the y axis, but gets altered on the z, which is the axis that a 2D sprite in the UI system would rotate, and it's going to rotate on its pivot point. But we do want to rotate the z-axis in 2D. So that took me a little bit of time to figure out, but once I did, in this single line of code like this, we're able to readjust that rotation to match that of the player in real time, and also the map. So if we go back and look at the map, the mini-map, while it's turning, you see the compass moves as we turn the player. The compass and mini-map move in sync. So that little bit of code, essentially it's 3 lines of code that handle it in the update, because I don't really count this. You know, this is a line of code, or a little block of code, but it's just checking if the object's null. But the meat and potatoes of this is happening in this line of code here, and then for the camera positioning, top-down camera positioning, it's these 2 lines of code here. So 3 lines of code total, along with a couple of references to some values here and some objects. So let's run that again. This time we'll run around the world a little bit. And so, yeah, so let's, so we're running north. You can see we're running north. If we look at the mini-map, you know, we're running north, north, north toward the trees here. That's what it shows on the mini-map. As soon as we turn left, it rotates. We're going back south straight to the building. So I'm going to turn a little bit more west. And we're going to hit the sprint button to run a little faster. So you can see our mini-map is working. The compass is moving with the direction. Now there's still, this third-party controller does not like these hills and waves in the terrain. If you're on a flat surface, it works flawless. But as soon as you throw in this, so, you know, like I said, later on we're going to be replacing the third-party controller here, third-person controller, and that will eliminate or fix all these issues. But the main thing is we have a mini-map that's following the direction that we're actually running in this 3D world, along with a compass that rotates around with it. So let's rotate there, so we can really flip around 180. So there's our tree there. If we stand still, it's facing south more or less. We keep rotating. There's east, there's north, west, back to roughly south. Wait a minute, that might be off just a hair. Let's see. Okay, I'm facing just a little bit off between south and east now. Let's do a rotation. I know. Probably just looked at it wrong. Yeah, it's about in the same direction. Okay. Yeah, so it is working. I just wanted to make sure. But because that, like I said, one line of code handled that, and the actual rotation of the compass sprite. And if you go ahead and research some examples that are on YouTube and some things you'll see all these different things that people are doing, all these calculations, and they're getting various, you know, things converting between, you know, radians and Euler angles and getting positions and all this of 2 different objects, and they make it a lot more complicated than it has to be. And for this style mini-map, this works perfect. Originally, I was thinking about doing a compass which would hang down at the top of the screen. It would be like a horizontal bar, and you know, you have the compass that kind of floats with a needle, and you have a continuous scrolling north, south, east, west kind of band that goes back and forth. But I went ahead and implemented it this way since I already had the mini map, and I kind of didn't like having a plain border around the mini map, and I was thinking, well, I could do just a nice little 2D sprite border around it, kind of make it look better. But then I said, well, why not turn that into the compass and have it rotate with the mini map? So that's what I did, and it seemed to work well. So that's it for this session. Like I said, next session or next few sessions we'll be getting started on this UI system. I have already, like I said in the beginning, I described visually how we're going to lay out our 2D backpack player inventory screen, and that's the first thing that I want to build and show you how we put that together, and then we'll essentially go from there and go through the different phases of that. So it may be, like I said, I foresee at least 3, maybe 4 streams. I'm hoping we can do it in 4 streams, but it may stretch longer than that. I don't know what we're going to run into yet. So stick around, come back. Please join us on any future streams. Again, subscribe to this channel if you want to be notified of the next time we go live and to kind of keep up on it, And you can also interact in real time here with our stream and in the chat. So anyways, I'm just looking at my dashboard and it's showing now in this one saying videos unavailable. I hope it's being ingested by YouTube properly. I hope it's not a YouTube issue, because I'd hate to have to redo the stream a 3rd time. So anyways, we'll leave it at this for now, and hope to see you on the next one. Thanks again for coming. Hopefully you learned a little bit out of this, how to create a compass and a mini map.